Alrighty then, corn children. It is a good day for mathematics. So let's do volume of revolution, washer method, part 2. If you haven't watched part 1, well, watch it. Alright, so here's what we've got. It says find the volume of the solid form by revolving the region bounded by f of x and g of x about the x-axis. All right, so here's f of x, whoop. There's g of x, whoop. Without too much work, we can find the points of intersection at the origin and at 1, 1. I'm assuming that's good to go. So this is the region right here that we're revolving. We're revolving it around the x-axis, also known as y equals 0. Now, this is key. Because the axis of revolution is horizontal, when we use the washer method, the rectangle that we draw needs to be perpendicular, therefore vertical. In other words, this little rectangle represents all of the rectangles that I will be revolving. It is drawn vertical because the axis of revolution was horizontal. And that defines for me the fact that there is a small change in x for the width of each and every one of these rectangles. All right, so once again, from video part 1, here's what's going to happen when we take that rectangle and revolve it around the axis of revolution. The bottom edge is not touching the axis of revolution, so we are going to get a washer. There it is. Do you see it? It has a hole in the middle because of this gap. All right? So we learned from video part 1 that we are looking for an outer radius squared minus an inner radius squared with respect to x. That's dx. You need that there. Now in our example, this region goes from 0 on the x-axis to 1 on the x-axis. I am looking at the x coordinates of the points of intersection. Yes, the y ones are the same, but that's just a coincidence. So 0 to 1. All right, so pi r squared height, pi r squared height. Outer minus inner. All right, here we go. Capital R of x. Put your finger on the axis of revolution. Put your other finger on the rectangle as far away as you can go. You are now touching the outer radius, capital R of x. What's your top finger sitting on? I'm on f of x. What's your bottom finger sitting on? I'm on 0. So our outer radius in this problem will be f of x. Yes, I know it's a 0, but I'm just getting you through the theory. Top minus bottom. F of x minus 0 squared. Outer radius squared. Minus. All right. Put your finger on the axis of revolution. Put your finger on the closest edge of that rectangle. Top minus bottom. What's your top finger sitting on? I'm on g of x. What's your bottom finger sitting on? I'm on 0. So the inner radius, little r of x, and yes, I know you don't have to write minus 0 with respect to x. Hey, cautionary note, when you're using your graphing calculator to type these in, when you do the numeric integration here, the calculators automatically put a set of parentheses here. So you're going to have to add the first parenthesis on your own. You can't use that first one. All right, so let's assume that you type incorrectly using your calculator. I mean, you can do this by hand. It's pretty simple given the functions. You should get that this integration is 0.3, but there is also the scalar of pi. Yeah, I know, right? All right, now here's what we're going to do. We are going to change the axis of revolution just to mess with you. All right, same region, but now let's pretend that we are going to spin this about the line x equals negative, y equals, horizontal line, y equals -1. So here's what we've got. Now this isn't drawn to scale, but let's pretend I'm spinning it here. This is now the axis of revolution. Not that one, this one. How does that change the problem? Well, it's still going to be a washer. The region is still from 0 to 1. We're still going to have an outer radius and an inner radius. But the outer radius is different. All right, here's how we do this. Put your finger on the axis of revolution. It's down here. Put your finger as far away on the rectangle as it can go. This is now capital R of x. And it is top minus bottom. What's your top finger on? F of x. What's your bottom finger on? -1. It is minus the -1. Yes, I am aware that that becomes addition. Think about it. Our radius went from here to there. It got bigger. But if you just do top minus bottom, it takes into account that we have widened the radius. I know, it's genius. All right, capital R of x squared minus the inner radius. Put your finger on the axis of revolution. Put your finger on the rectangle as close as you can get. That's this bottom edge. This distance is little r of x. And yeah, these are functions of x dx. Yeah. All right, what's your finger on? Top minus bottom. Your top finger is on g of x, and your bottom finger is on -1. So the inner radius is g of x, top minus bottom. Yeah, with respect to x. That dx is the width of these rectangles. It is the quote-unquote height of these cylinders. It's this value. All right, so if we type this in carefully, and you can simplify if you want, I don't care how you type it, keeping in mind the graphing calculator automatically puts those parentheses in, you should get, where's my answer? There it is, 0.967 pi. Now, you can either leave it this way, or you can use your pi button and get me a decimal approximation 3 decimal places. Hey, enjoy that now. Awesome.